Basic PLC discrete logic. In this presentation, we're going to cover the basics of examine if on and examine if off type inputs for PLC programming. Well, let's start off with some basic information that we all need to be aware of. The outputs in a PLC will only be on when there is a continuous path of true inputs in the rung. And remember, true inputs are ones that are color changed. Depending on the brand of the PLC, it'll either be marked with a red dot or red square, or perhaps an overlap of color over the entire symbol. In either way, the color is what indicates that we have a true symbol. For this installation on the top rung, we can see that the two inputs are both true. And because of that, we can imagine or picture current flowing through these. And the only reason it's flowing through is because they are true. This would mean that this first output would also be true or on. On the second rung, we can see that we have two inputs that are false. And because they're false and not color changed, it would then lead us to believe that there is no current path through this rung, and that would be correct. It would mean that this output remains off. Finally, down on the bottom, we can see we have 1, 2 true inputs. And again, because of that, current would travel through and make this output here on. This is an important step to confirm and understand prior to moving on to the two different basic types of input instructions. The first one we're going to look at is called examine if on. Often it's going to be abbreviated as XIC. Now, this is the type of symbol that we would expect to see, and although it seems to look similar to a normally open contact, it is not. Examine if on, examine if closed mean that the PLC is examining this connection right here. My input device is applying voltage, and if there is voltage, that would mean on. So we could say here, presence of voltage would mean on. Another way to look at this would be if this push button were to close. Now, what this means is that when we have voltage present, our symbol will go true. So if there is a presence of voltage, my input will go true, and depending on what else is connected in the rung, an output may go on. So let's take a look at this particular scenario, but with two separate input push buttons. Here we have two separate PLC programs. One has a normally open push button, which has not been pressed, and the other has the push button pressed downwards. At this point, what we can safely assume is that there is no voltage being applied to the input of the PLC. So there is no voltage. Now, because there is no voltage, it means that the input will not be examined. And because of that, it will remain false. Since the input remains false, the output that's connected on the same rung will remain off. And of course, any load that is connected to the output of this PLC would also remain off. On this lower rung, we see that someone has pressed down the push button. Because of that, there is now voltage. And because there is voltage, it means that this input instruction will now go true. And because of that, current would flow, imaginary current, through the PLC program, and my output would also go on. Now, because the output has gone on and we have a load connected, we can safely assume that the light will also turn on. Now let's take a look at the other type of PLC input instruction. This one's known as examine if off. It's typically shown like this, XIO, and it resembles a normally closed contact, although again, I would caution you in drawing that same similarity. Examine if off, examine if open means that the voltage here will be examined, and depending on what is found, that input instruction may go true. So in this scenario, we're only going to have a true symbol if there is a lack of voltage. So we could say no voltage at this point would then equal what? Off. And because of that, our symbol here, or the input instruction, would be true. So let's see how this scenario plays out with a full PLC rung, because all I've done is started with the input and we haven't discussed the output yet. Well, in the top rung, we have a normally open push button, examine if off, input instruction, an output and a light, and then the exact same on the bottom, except now the push button has been depressed. At this point, we can see that there is no voltage. And we would say that that would be off. The push button is off or open. And because of that, this input instruction will now go true. Because it's true, fictitious or imaginary current could flow through this rung to the output, and the output would then be on. Now that the output is on, any associated loads would also be on, and so if we had the light there, we could say the light would most definitely be energized. In the lower rung, we see that now the push button has been depressed, and now there is a voltage present. Well, if there's a voltage present, remember, this input will only go true if there is no voltage, and so it's a little bit different. In this case, it would be false. And because it is false, the output would remain off. And any loads connected to that output would also remain off. PLC input logic can be a little bit confusing initially, but as time goes on and you review the basic concepts, clarity tends to replace the confusion as we look at more complicated PLC programs.